Hello and welcome to another video on orbital mechanics. I am still working through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition, and we are up to problem 2.1. I've skipped over a few problems in chapter 1 because they're very heavily focused on numerical problems, and I want to try and stay on the orbital problems, and also some of the problems at the end of chapter 1 are incredibly tough and I'm still working on them. So I skipped over to chapter 2.1 and the chapter 2, and the problem 2.1 is asking us about two particles of identical mass that are acted on only by the gravitational force of one upon the other. If the distance d between the particles is constant, what is the angular velocity of the line joining them? So let's just draw that. So we have two particles, equal mass m, and there's a gravitational force between them, and d here is constant. Now, in order for d to remain constant, they mustn't move towards each other or away from each other, and for that to happen, they must be orbiting each other at a constant distance, and for that to happen, these forces must balance. So this is the centripetal force, which isn't really a force, it's just models of force. And this is the force of gravity here, and this is the center of gravity here. So we know that the force of gravity from 1 to 2 is equal to the gravitational constant, the mass of 1 times the mass of 2, which are both the same, divided by d squared. And so this is this direction. We don't need to deal with both. We're just trying to find the equation for the angular velocity. So that is question mark. We know that the equation for the centripetal force is equal to mw squared r, and that comes from ma, where a equals v squared over r, and v equals wr. You put all that together, you get this. So we can say that mw squared r equals, and r is the distance from one of the particles to the center of gravity, which is halfway between, equals gmm over d squared. Cancel one of the m's. R equals d over 2. So we have w squared equals 2gm over d cubed, and then angular velocity equals the root of 2gm d over d cubed. I really need to stop saying w when it's angular velocity. And that's the answer. Pretty straightforward. This is as simple as I could make it. If you have any questions, leave them in the comments below, and I will throw up a very basic MATLAB script as well that does this. Thank you. Goodbye.